So let's go ahead and let me make sure I'm connected. I think I am, but yeah, I am. Module 2 homework. Let's see what is the order of the day. Oh, so short, 21 questions. What is the topic? That's the reading assignment. Remember, where you basically just go through and it's multiple choice and it's just familiarizing you with whatever vocabulary you have. So usually I'm going to start with just the actual homework so we can figure out the technical component, and then we'll do the reading assignment if we have time next time. I mean, you saw how the tests were. Typically the tests are modeled after the homework. So, we'll kind of do, an understanding of what the words mean as we go through the homework. And then that'll make the reading assignment easier for you to do on your own. So, rewrite the following statement so that the likelihood... Okay, so rules of probability basically mean two things, right? The probability is always some number between 0 and 1. And if you look at the sum of the probability of all possible outcomes, that always adds up to 100%. So a weather forecasting company indicated there was a 10% chance of rain today. So it would be here, where we want to convert the percentage to a decimal. So there's a 0.1 probability. So that's just the normal conversion between decimals and probabilities. Which of the following can't be probabilities? Okay, so negative values are not okay. And numbers bigger than 1 are not okay. Okay, so those are the main things. So if we look at all these, 3/5 is 0.6, that's fine. Negative 0.6, for me, that's not okay. 0.04, that's a 4% probability. Square root of 2, if you type that in your calculator, that's about 1.41, so that's too big. 0 is a fine probability. It means it's never going to happen. 1 is 100%, always going to happen. 1.39 and 5/3 are both bigger than 1. So those cannot be probabilities. So it's actually asking which ones cannot be probabilities rather than what can. So 1.39 cannot, 5/3 cannot, negative 0.46 cannot, and root 2 cannot for me. Any questions there? Okay, in a certain study, the chances of movies with a female lead are 19 out of 100, so that's 0.19 if we do a decimal. So that's what they're asking here, just change that to a decimal. Again, I promise the first couple modules in this class are pretty basic. We'll get to some more advanced stuff as we move on, when we get to hypothesis testing and stuff. This just means convert to decimal. So what was your... So if yours was not out of 100, if it was 5 out of 20, you would do 5 divided by 20? 0.05? Yeah. But if it were something else, you would just actually type it in the calculator and figure out what that is. 9 divided by 25 would be 0.36. Yeah, and you would just do 9 over 25. Okay. Express the indicated degree. So these are, again, just rules of probability based on a survey. There's a 50-50 chance. Okay, so that would be appropriate. So 0.5. I will say this is one of the things that you hear people say in sports and in other walks of life. I heard Drew Brees say it once in a sports an NFL game. They said, he made this really difficult to complete pass, and they said, what'd you think the probability was he was going to catch that? And he said 50%. He either catches it or he doesn't. So just because there's two outcomes does not mean the outcomes are equally likely. So that's one thing that people often make the mistake of in stats. They'll say, two outcomes, therefore it's 50-50. But, right, you could have the outcome of rolling higher than 1 on a die versus rolling 1 on a die. Those are two outcomes. One is 5 out of 6 probability. The other one's only 1 out of 6 probability. Or same as playing the lottery. You win or you don't. That doesn't make it 50-50. Okay, so we've got some big number that say they use social networking, 3 say they do not. Sometimes on these they can trick you because if they give you the part that says they don't and the part that says they do, the total is often what you have to divide by to get a true percentage. Does that make sense? Again, I kind of parse these. I don't think necessarily reading everything is a good idea, but what's the probability a randomly selected person uses social networking? Okay, so that would be the amount that say they use, which is this 3594, but we have to divide it by the total of everybody that's surveyed using it or not using it. So again, if we go to Desmos, that'll, again, your numbers are probably going to be different also. So let's go ahead and do, I don't know. Most people use the graphing calculator, so I'll use it, but you could use the scientific one as well. So 3594, and then divided by the total, 3594 plus 1340. Didn't do the plus, so that messed everything up. Okay, so 3 decimal places, 0.728 for my answer. Again, yours are going to be a bit different. Is it likely for a respondent to use social media? Yes, it's bigger than 0.5. Right. Yeah. Just comparing it to, they're saying if it's less than 50%, it's not likely, but if it's more than 50%, it is likely. Assume that boys and girls are equally likely. Find the probability that when a couple has 3 children, there is exactly 1 girl. So we could think about this in different ways, and we'll learn about something called the binomial distribution or the Bernoulli distribution that'll allow us to do that. But what would be the probability of, say, maybe we should write something down for this one. So let's say, I think I have something in. Maybe I have to. I'm in incognito, so I don't know if it's gonna. Yeah. Virtual whiteboard. Usually I just use Google Notes or whatever, but I'm going to try to just use a generic one. No, got to sign up. I think I have some sort of program on here. Note something maybe. Is there a paint? All right. Where's my other do homework? All right, I'm just gonna have to open a new. I thought I put something on here specifically for this, but I was having problems logging into usually I use Google Drive, but I had to log into incognito. And my thing's having some problem. Let me just go to webmail, and I think I can just use OneNote. Ugh, it's gonna make me send a Duo message and everything. Sorry. I was getting a bad request for. Nothing's free and everything's difficult. All right. Let's go to apps. Do we not have OneNote? OneNote, there we go. Okay, finally, something I can write on. Okay. This is the longest explanation ever for something very easy. Okay, so can I draw with this at least? No. Draw. Pen. Great. Okay, so it says what is the probability of exactly one girl out of 3 children? So, I mean, there's obviously 3 ways you could do this, right? You could go girl, boy, 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 girl, boy, or boy, boy, girl, right? 3 possible ways. How many possible ways could you do this? Well, if you think about all the possible ways you could have kids, you could have 2 different choices here, assuming boy and girl only, 2 choices here and 2 choices here, and they're independent events, so you would multiply them and get 8. So for that reason, the probability here would be 3 over 8, or 0.375. So okay, but the probability was exactly 1 girl.
Not mine.
Oh, what was yours?
3.
3 girls? There's only one way to have 3 girls out of 3 children, right? Girl, girl, girl. But there's still only 8 ways to have 3 kids. So your probability come out to 0.125. Yeah, so yours would be and does appear effective. I'm assuming they're judging that against just a because it doesn't say any other probability that they expect to occur. So I would say no here. It doesn't appear effective. If you had more than 50%, maybe you would say effective. Okay, so finally we're getting into some stuff where we're going to use StatCrunch again. So this is when we have something called like weighted probabilities. Now, you know, if everything had a number of unlicensed software packages X, they're giving you just different numbers of software packages. If everything were equally likely, then you would have 25%, 25%, 25%, 25%. But here you have different weights of probabilities based on the number of packages. So if you want to figure out the weighted mean, the way you do that is, in general, for a weighted mean, for weighted average, let's say, you do just x1 times p x1 plus x2 times p x2, and you just continue this dot dot dot.
Sorry, what was that for that px?
Probability of x2, x1 times probability of x1, x2. It's let me you would do 0 times 0.125 plus 1 times 0.375 plus 2 times 0.375 plus 3 times 0.125. And this number would give you the expected amount of, was it faulty software package? And I'm just typing it into my calculator here. So I meant to make that a plus. So I'm getting 2.25. So you would expect about 2.25 here. Okay, so that's doing it by hand. Let me show you the magic of StatCrunch for doing this problem. So, again, whenever you have this little double rectangle, we can open this in StatCrunch. That gives us a new window. So, let's see how we do this. We do stat, calculator. Okay, stat, calculator. The same way. It's one above summary stats, which we were using last time, and then we go all the way down to custom. And then we just pick our variables and our weights. So our variables was the unlicensed packages, and the weights were the probabilities. And then you just click compute, and it gives us the mean and the standard deviation. Did I do something wrong when I computed? 0.375 times 1 plus 0.375 times 2 plus 0.125 times 3. Oh, it should have been 1.5. I just typed that wrong, so human error on my part. But the answer here should be 1.5. Sorry, I don't know why I wrote it wrong. I just typed something. I think I wrote an extra multiplication, but this should have come out to 1.5. Race. And then, sorry. So this should have been 1.5. Sorry about that. Okay, so where did StatCrunch go? I don't know where StatCrunch vanished to, but let's okay, so the random variable is the number of unlicensed software packages. That's X. The possible values are 0, 1, 2, and 3, and they are numerical. So, yeah, so that would be C. Okay, so I don't know why they gave us this if they didn't want us to figure out the weighted mean, but now we know how to figure out weighted mean on StatCrunch. It will come up later. Sorry, I expected them to actually use this data and have us compute something. Okay. On these, almost always, it's, yes, the table shows a probability distribution. How do you figure that out for real? Well, you just add the probabilities, and if the probabilities add up to exactly 1, then it's a probability distribution. So what I'm going to do is I'm just going to go to Desmos, and I'm just going to add up all those numbers. 0.029 plus 0.163 plus 0.308 plus 0.308 plus 0.163 plus 0.029. And we get exactly 1. So yes, this is a probability distribution. Let's see if there's a way if we can just add up that column in StatCrunch, because there probably is, so I wouldn't have to type it out. So let's open this. Oh, and it wants us to do the mean of the random variable, which means we're going to have to do the thing that we just did anyway, the stat calculator custom. But I just want to see if there's a way to sum everything up. Calculator, data. Is there a quick sum function here? Let's just do a summary stat by column and see. Probability of X. Sum. Probability of X and sum. Click compute. We get the sum as 1. We were doing summary stats last time, remember, for 5-number summary, Q1, median, Q3, min, max, stuff like that. To get this mu, the mu is just the weighted mean again. For that, we go to stat, calculator, all the way down to custom, the thing we did last time. Our variable is X, and our weight is P of X. And we get our mean is 2.5. It also gives us our standard deviation if they happen to ask for it. This is part 2 of 3, so I'm assuming they might. So 2.5 is our mean for this problem. Or
That symbol means mean?
yeah, mu means population mean. So in general, So let me finish this and then I'll write. But in general, mu would mean population mean. X with a bar on top would mean sample mean. S, sigma would mean population standard deviation, and lowercase s would mean sample standard deviation or sample error. So this sigma right here, this means population standard deviation. So that's the second number here, and it just has one decimal place, so 1.1. And that's it. So the next ones coming forward are going to be pretty similar. Let me just write that down for you real quick on the so population parameters. So we have mu. This is the Greek letter mu. So this is population mean. And then we have sigma. Sigma. This would be, I don't know why I did that also. Sorry. So then we have sample.
This might be a stupid question. How do we know when we're to use the calculator and columns versus going in and using the other parts?
We just kind of have to practice module by module to see what we're going to do. That's like the tricky part of this course is like, okay, here's the problem. I kind of know how to interpret it. I have to remember where to go in StatCrunch. So it's just kind of like, this happens at like lots of jobs, right? You just get specialized software when you're in the hospital. Okay, you have to learn how to use Epic. For this class, we just have to learn how to use StatCrunch and where to go.
So nothing in a question that would tell you, like, definitely go.
No, and if you go to the textbook, they'll show you complicated formulas and tell you how to do it by hand a lot.
Okay.
And sometimes they'll even say, okay, this is how you do it in Excel. Because, like, you could learn this class via the TI-83, Excel, Google Sheets, by hand, using charts. But StatCrunch is the easiest way, and it imports all the data so we don't have to type it in. So I think it's the easiest way. So this is sample mean. Oh, I forgot to say this is population standard deviation. And S would just be sample standard deviation or standard error. Sometimes this is called. It has to do with the number of degrees of freedom you have there. Okay, so for this one again, is it a probability distribution? Let's just check that they add up to 1. I don't want to type it in again, so I'm going to use StatCrunch. Again, that's just, I go by the column, and I want to add up my P of X column, so I just go to sum. It adds up to 1, so I know the answer is yes.
It's a trick question.
Why is it a trick question? It adds up to 1. We're asked to hear and determine whether population, if population.
Because the X1 isn't numerical.
Oh, fair. Fair. Yep. For so many semesters, they had it where it was always yes. But yeah, in terms of weighted values, yeah. This would be a categorical probability distribution, but not a numerical one, yeah. So it's not a random variable. Fair. It's categorical instead of numerical. But the sum of the probabilities is equal to 1. All of the probabilities are fine because none of them are negative or bigger than 1 or anything like that. Okay, so yeah. Thank you for catching that. They're still going to ask us to do the mean and standard deviation, it looks like, which we still can do for categorical data. Or can we not?
It told me no.
It does not show a probability distribution. Yeah, it doesn't make sense because you can't multiply the weights by the probabilities. You can't multiply left by 0.63. So it should be B here. Yeah, and then similarly with standard deviation, you can't do that either. So, yeah. Yep. That's a good one. This one, we're fine though. We're back with random variables. Let's check again. The probabilities add up to 1. We do that by stat, summary, column. We're checking the sum of P of X. And we get 1, so yeah. So again, we can do the mean and standard deviation. So that is calculator custom. Calculator custom, we pretty much, I think the only thing we really use it for is this when we're doing weighted means. But it does come back a little bit later in the semester, so it's good to remember. And weighted means are something that come up quite a bit, just in life in general. Sometimes people don't recognize them, but they're around us. Okay, round to 1 decimal place. So for me, 0.874 rounds to 0.9. And the standard deviation, 0.78. They're still asking for 1 decimal place, so that's 0.8. Okay, so here we're getting into binomial distribution. So I think maybe this is a good place to stop, and we'll just do the next 10 questions next time, and you can try and catch up on the reading assessment. So let me go ahead and stop this recording and see if that worked.
And this is all due next Sunday?
Next Sunday, yeah, so that's February 1st for us.